Hi, my name is Muhammad Nuqman Haris bin ROSLAN, and my friend name is Muhammad NURIHSAN bin YAHAYA, ZAIM ZAKWAN bin ZAIDI, and AKHTAR ANNASHAR SYARIF bin LILA ATTAHRIR RAZIQ MUKAMIL. Today, I am going to present our mini project for this subject, which is automatic water tap. The objective of these projects are to prevent the spread of coronavirus, which is COVID-19, in Malaysia. Second, to help to use a water tap without the need to touch the knob. In this time of crisis, use of public water tap are considered dangerous because it may help to spread the COVID-19 virus widely through object touching. This project aims to help to use a water tap without the need to touch the knob. Basically, by sensing the presence of hand near the faucet, the water will flow automatically. It consists of three main components, which are embedded microcontroller LPC1768, ultrasonic, distance sensor, and solenoid valve.
As you can see in the flowchart, the process starts with the hand sensor by using the ultrasonic distance sensor. If there is any hand detected by the sensor, yes, then the processor LPC1768 will receive the information from the distance sensor and it will allow the valve to open and the LED will start blinking. And however, if there is no hand detected, then the valve will not open, the LED will not blink, and the process will repeat back to the hand sensor. Now, this is the circuit diagram. This is the processor LPC1768. This is the ultrasonic distance sensor model HCSR05. This is the solenoid valve. This is the power jack for the power adapter, the diode, and the transistor. As for the connection between the components in input and output pins, from the processor, pin 16 is connected to the base of the transistor. Pin 17 connected to the echo pin of the distance sensor. Pin 18 connected to the trigger pin of the sensor. The voltage in pin are connected to the positive pole of the adapter. The ground pin of the processor are looped to the ground of the adapter, the ground of the sensor, and the emitter of the transistor. The collector pin of the transistor is connected to the first terminal of the solenoid valve, while the second terminal of the solenoid valve is connected to the positive side of the adapter. The anode of the diode is connected to the positive pin of the adapter, while the cathode of the diode is connected to the collector of the transistor.
For this project, we are using the LPC1768 Cortex-M3 microcontroller. For this microcontroller, we use only 3 output pins and input pins, which is the pin number 16, 17, and 18. Now, why do we choose the pin 16 until pin 18? This is because at pin number 16, it has an analog to digital converter, in which we use as the ultrasonic sensor here at pin number 16. Therefore, for the output pin, which is the LED and valve, is located at pin number 17 and 18. Now, because this pin select 1 has 2 functions, which is as the GPIO and analog to digital converter, we need to set the values so that the microcontroller knows at which pin it acts as a function. For an example, at pin number 16, we use the sensor which is the analog digital to digital converter. Therefore, we need to set the bit number 16 and 17 as this function. So, bit number 16 will become 1, and bit number 17, for bit number 16 will become 1 here, and bit number 17 will become 0 here. Now, for the pin number 17 and 18, because we want to use it as the GPIO, therefore, we need to set the function as 0, 0, and 0, and 0. Therefore, the others slots will also be 0, thus giving us the equation or the value of 0x0001 0000 after filling up these values. Now, for the FIO direction, based on the notes, it is to configure whether the IO pin is used as input or output. Therefore, from here, the input is actually set as 0, while the output is actually set as 1. Therefore, because at pin number 18 and 17, it is P0.25 and P0.26. Therefore, at FIO direction 0, and bit number 25 and bit number 26 will become 1 because it is the output, and at P0.24 is the input. Therefore, at 24 here, it will become 0. And then, when we change it to hexadecimal, it will become this value. Moving on is the FIO pin. Here, based on the notes, FIO pin is the status whether it is high or low for each IO pin. Therefore, for the input or pin 16, we set it as high, and for the output, which is the LED and valve, we set it to low, therefore 0. And then when we convert it to hexadecimal, this is the value. So the pin FIO0 pin at the address given here is has the value of 0x01000000. Now, for the FIO set here, and from the notes, FIO set is actually to set the particular IO pin to high. So we need to set the pin 26 and we need to set the bit 26 and 25 as high, because we use the pin number 18 and 17 is located at P0.25 and P0.26 here. Therefore, when we set it to high, the hexadecimal value is given by this. Lastly is the FIO clear, which is to set the particular IO pin to low, meaning turning off all the output pins. Therefore, when we need to turn off the output pin, we need to set it to high. Therefore, bit 25 and 26 will be set to 1, thus making the output pin here turning off. Now, this is the part where the valve and LED closes and opens. First of all, the register 6 is load with the value of R4, and R4 is actually our value of FIO pin, and from here the FIO pin is actually equals to 0x01000000. Now, we need to load the register 5 equals to 0x01000000. Then after that, we need to do the AND operation, whereas the operand R6 and R5 undergoes the AND operation, and then the values are stored inside the register 6. Then the value of register 6 is compared to the value of 0. If the value is still 0, then the operation still continues, meaning it will branch to equal valve close, meaning that the program will go into a loop from here to here. If the value of register 6 is not 0, meaning it's equal to 1, then it will skip this branch and moves to the loop register R5 equals to 0x06. Then storing the value of R5 into register 2, which is register 2 is equal to the direction, to the set, which is to set the particular IO pin to high, meaning that the LED and valve will not turn on. After it's been turned on for a while, it undergoes another comparison, or compare register 6 whether it's equal to 1 or not. If it's still equal to 1, the water or valve is always going to be open, or water is going to run. Now if the register 6 is not equal to 1, meaning it's 0, then it goes to this branch which is equal to valve open. If the value of register 6 is not equal to 1, which is 0, it will skip this branch and then moves to the load register R7 equals to 0x06000, and then storing the value of this into register 3, in which register 3 is given by this address, which is the clear instruction, thus turning off all the output of LED and valve. Then when we build the project, there are no errors and 0 warnings. Then we need to run the debug. And that's all from me. Thank you for watching.